Hi, in this video we are going to create and execute an Ansible playbook that will create an NSX distributed logical router in our vCenter environment. So if you're following along in the Ansible course, if you remember in the previous exercise, we created 4 logical switches. Each logical switch in NSX represents a different IP subnet, so we'll need to implement routing services to enable for IP connectivity between the 4 logical switching subnets that we created. So let's look at the playbook that we use to create a distributed logical router. First that we need to do is we have 3 tasks that gather 3 different management object ID values from vCenter. The 4th task, to create the DLR, will make the API call into vCenter to create that, and it needs these management object IDs to be able to specify the appropriate location and parameters for the DLR creation. And then finally, the 4th task here, single task to use to create the DLR. Now let's look in the playbook to see what this playbook looks like. So first ones, we've seen these gather MOIDs before. Again, all of the gather MOIDs uses this common module, vCenter gather MOIDs. You can see here. The difference being that everything's identical between these tasks except for one value. So for the cluster, we put in the cluster name, which is the plain text name that we can get from our vCenter environment for the cluster that we want. Now in this gather the data store task, we can see everything else is the same, except instead of specifying the cluster name, we specify the plain text name of the data store from our vCenter environment. And finally, the same for port group. Everything else is the same, and we specify the plain text name of the port group, and this module will return back that MOID. And you can see each of these MOID modules registers the variable, and it specifies a name. So we have a variable called vCenter port group MOID that's created after this task is run. And if you look down here, we can see that these IDs are entered into the DLR creation task. So we specify the same IDs that we gathered here, so for this task to use in its API calls. So in this DLR creation task, we say, again, the state is present, and that's talking about both the DLR, but also the configuration for the DLR. So if we think about that idempotency principle from Ansible, right, we want, when Ansible runs this task, we want it to check and say, does this DLR exist? If no, create it. If yes, then leave it alone, right? But what if some of these other items are different? What if we've added an additional interface? And so Ansible is actually going to check all of these configuration items, at least the ones that would result in a change, right? And if you were to run this task, say right now, it's going to create a DLR that has 4 interfaces on it. And let's say if later you wanted to change one of these values, right, you'd come back, change it, and run this task just like this again. And let's say if I wanted to change this IP address here, for example, if I were to change that, run the task again on a DLR that's already created, it would recognize that there's a changed IP address and make that change. And so this ability for Ansible to recognize a present state, assuming the Ansible modules are written according to how they're supposed to be written, right? It doesn't extend to just the object itself, but also all of the configuration parameters that are associated with the object. Okay, and we can see here, after specifying its name, we specify some interfaces, right? You give it an uplink, and if you notice the logical switches that we created last time, we created a transit LS, right? And when we specify this name that we're calling our uplink, we're saying that it is connected to the transit LS logical switch. And that will be, there will be 2 devices that will connect to the transit logical switch, this distributed logical router, and in the next section we'll create an edge gateway that will be the northbound router for the virtual machine networks. And so both of those 2 routers are connected to this common segment, and so we'll show how they can ping each other and such. The web LS, remember, we created that web logical switch, and so we are now creating a routed network for this. So, and if you were to deploy workloads, right, you're going to deploy a virtual machine onto a logical switch, right? So you might put that the NIC for that virtual machine on this WebLS, and then you're going to need a default gateway. Well, here's that default gateway information, right? It's this distributed logical router. And we did the same for app and the DBLS interfaces. And we specify a default gateway. That is an optional parameter. In this case, we're going to use that. Remote access is true. And this username and password, these are for accessing if we went to SSH or Telnet or console into this device. Sorry, SSH or console into this device later. This is the password that we'll use to gain console access to the distributed logical router. And we specify if we'd like high availability. The control virtual machine, we're going to leave that as false for this lab environment. And finally, we register these values in our Ansible shell, or our shell environment. So I'm going to go ahead and copy this. And we'll create this playbook. bi.yaml, and we'll type I for insert, and I'm just going to make sure that's copied. Okay. Right click to paste. Looks like we got a nice clean paste, so I'll press escape to leave insert mode, :WQ. Enter. And then we'll run our playbook. -I for inventory. The name of our inventory file is host. And then, what was that? Create DLR. Go ahead and run that. And we should see that it runs through these gather tasks very quickly, but then it'll get to this DLR creation task, and this will take a few minutes. It has to go out and create a new DLR control virtual machine and power on that virtual machine before this returns back. So I'm going to pause the video while this runs, and I'll resume shortly. Okay, we're back, and we can see that our playbook has completed successfully. So we can verify, look at the GitHub course documentation and see that our output is the same. We ran 4 tasks. All 4 came back okay. 1, the DLR creation resulted in a change. So now we're going to go and validate results. If you notice here, we're going to go in and look to make sure in our vSphere web client that this logical router has been deployed. We're not going to execute any pings yet. Reason why, if you look around in the vCenter environment, you realize there's not much there yet. So we'll go ahead and do some pings to demonstrate our routing capabilities in the next module. For now, I'm going to open my vSphere web client, and I'm going to go home. And from the home page, let's go ahead and go to hosts and clusters. And we can see we have a virtual machine running. That's our control virtual machine for the DLR. Now let's go back to, let's go up here to go to our networking and security menu. And I'm going to go to NSX edges. And we can see that the Ansible DLR that we created is here. If you'd like, you can double click on it and verify other settings that we created, such as the interfaces. Right under settings and interfaces, we can see each of the interface names and IP addresses and so on that we had in our Ansible playbook are configured accordingly. And that's the verification. That about does it for this module. Thanks for joining.